Welcome to this video on wiring planning and drafting best practices by SkyWire Studio. If you don't already know, SkyWire Studio is a cloud-based avionics wiring CAD application. It's free for everyone to use, but we do offer a paid subscription which provides access to automation, templates, and other advanced features. The templates and automation allow users to create professional diagrams in half the time or less compared to other methods. So in this video, we will review processes and techniques to plan an avionics installation and organize the drawing into multiple sheets. We'll review some common electrical symbols. We'll review the SkyWire Studio features and tools that are used to create diagrams, discuss layout techniques, and how to use the SDC data to create a full system interconnect. In this training, we'll consider a TXI installation with dual GDUs, a GTN, GI275 standby audio panel, and a GTX. It is not going to be a complete guide on how to wire this system. Some symbols you may already be aware of, just having read through Garmin installation manuals. You have the LRUs up here, which are represented as a box with the connector attached, connector name. You have shield symbols. The shield with a triangle for the pigtail represents a shield block termination. This goes to the back shell of your connector. You can review the Garmin installation manual for more details on the different types of terminations. Without a pigtail, the shield represents just a floating shield. It's not terminated. If there is a ground shown on the shield, it's an airframe ground shield. Splices are shown the same way as in Garmin installation manuals, with a rectangle and a cross through it. We offer a whole suite of symbols that I won't go over into detail with here, but they include switches, bus bars, potentiometers, headphone jacks, and other items that you would commonly use in an avionics installation. So the first layout tip that we have is don't forget that you can place connectors on either side of an LRU. You see in this example here we have 2751 on the left side of this GI275 and 2751 on the right side. They're the same connector, we've just duplicated them on either side to make the layout much easier. You can see if we had 8, 9, 27, 28 pins on the left side here, we'd have to route them with more than 3 wire segments, which would look more like a maze and be very hard to read. In this case, it was much easier to put the pins on the right side so it connects directly to the interfacing LRU. Similarly, you can also duplicate LRUs when you don't get a clean path between the pins. So if you find yourself routing connections that have more than 4 segments, or it just ends up looking like a maze, you just need to sit down and rethink your LRU layout. You can see in this example, we have a GTN 750 over here on the left side. It's the number 2 unit, and we have the same GTN 750 number 2 unit on the right side. This is all on the same sheet, which is okay. It's alright to have the same unit duplicated on the sheet. When laying out connections, it's important to keep the connection pairs tight, especially when they cross other connections at a right angle. So you'll see this at this location and these locations down here. The HSDB wires are kept really close together to distinguish themselves from the horizontal lines, such as this A-ring 429 line. Now, normally you would show connecting wires with a junction dot where they are spliced. In this case, it's obvious that they are not connected because of the different wire colors and the lack of junction dots. Some people, however, may be used to seeing wire humps. This isn't quite as common in many electrical diagrams, but in this case, if you're not familiar with this kind of a layout with the lack of humps, it's important to keep them spaced together. When running many connections across the sheet laterally, it's important to keep some spacing between the groups of connections for clarity. You can see here between RS-232 port number 3 and RS-232 port number 4 that we have a good spacing, allowing you to distinguish visually the two RS-232 ports without confusing them. You can also break out multiple connections like passenger headphones here. This is called fan out. When fanning out, SkyWire Studio will help you here by snapping the wires vertically so they all align nicely. Junction dots will appear where the wires splice off. Don't be afraid to use wire colors as a visual aid, even if they don't represent the actual wire color that you'll be using in the physical harness installation. Sometimes it's just nice to have different colors to break up the layout when you might be sharing many of the same color codes. You can also leverage connection labels to specify unit configuration as necessary. So you can see in this diagram we have the connects format for this RS-232 number 2 port. For RS-232 number 3 port, we have the Garmin VHF Navcom or NMEA 1 format. When daisy chaining connections, it's sometimes necessary to swap the pin orientation between the chain connections to prevent unnecessary crossings, and it just provides a cleaner diagram in the end. The diagram on the right shows an HSDB connection between the LRUs. What we're talking about here is the fact that we don't replicate the same pins in the same position on both connectors. So you can see that 2A out is on the top here, but 1B out is on the top on this one. If you had swapped those, we would have crisscrossing wires. This is also common with CAN buses. Some of your LRUs may have a lot of connections going into a single connector. In these situations, it's nice to have a longer connector to accommodate straighter lines. You can see in this diagram here to the right that there is a lot going on between RS-232, power, Ethernet, USB, config module. Providing a longer connector for 2751 here allows for you to fit multiple things in on that one connector between the circuit breaker, the grounds, the config module, and other items that may be off to the side in the diagram. Sometimes in Garmin diagrams, you'll see color codes defined as WBO for white, blue, orange. You can use text labels along with wire colors to replicate this in SkyWire Studio. So over here on the right is an example from a Garmin diagram where you see W, B, and O with the splices in the middle. Over on the left, we have white, blue, and orange as well. So SkyWire Studio also provides styling where you can use stripes or dashes to represent the connection or wire, physical wire. Sometimes you might use dashes to represent optional connections in a diagram. SkyWire Studio allows organizing drawings into sheets. So there's many different ways you can go about this, but my preference is to start with a power and ground sheet where you lay out all of the LRUs for your installation and pin out just the power and grounds. Sometimes these overly complicate an individual sheet if you're trying to show everything on one. For data, you may have one or multiple data sheets, such as with a large Garmin installation like this TXI installation. You might want to have a sheet dedicated to just HSDB to show that architecture. In a G3X installation, you might want to have a dedicated CAN sheet. Audio sometimes can fit on an individual sheet depending on the size of the intercom connections. For the audio sheet, sometimes you may find the need to break out the intercom from that sheet, so you'll show your ICS connections on one and audio connections on another, such as from other units that may provide oral alerts. EIS is always helpful to have on a single sheet, given how many pins can be on a GEA. Autopilot is a good one to have separated out as well. So when it comes to sheet organization, I'd be curious to hear, for those that draft your own diagrams, how do you organize those drawings? Are you creating multiple pages where you're handwriting the diagram? Do you have a Visio doc with multiple tabs? What does that look like and what works best for you? If you're the one reading a diagram for either troubleshooting or just building a harness, what type of organization makes sense to you? What would you like to see in a diagram? Leave a comment in the video and I would love to hear more from you. So getting into the planning. In most Garmin installations, the GDU, or the display unit, is the brain of the system. So you're going to start from the GDU and work your way through the various integrating LRUs. You'll see that the display units typically have many interfaces compared to some of the ancillary equipment that works with the GDU. So you'll have RS-232, ARINC 429, HSDB, 485, discretes, and so on. So where do you start? Usually I'll start with power and ground connections since it's just a convenient one to begin with, as all the equipment will just reside on one sheet. So you can get a good visual of what you have and make sure you're not missing anything. For this video, I've referenced Appendix B of the G500, G600 TXI installation manual. So let's get started. We'll head over to SkyWire Studio and start on sheet 1, or our power and ground sheet. So when we're talking about the power and ground sheet in particular, it's helpful to use connection labels to specify the wire gauge that deviates from the standard. So you might see in a Garmin diagram, there might be a note such as all wires 24 gauge unless otherwise noted. You can add a note to all of your sheets that says something to this effect, and then only label the wires that deviate from the 24 gauge. This is common for a lot of the power and ground pins. You might also see that the wire gauge requirement varies based on the length of the installed wire. If this is the case, you could just provide an annotation next to that pin that specifies the requirement. You can also look to the STC data to determine how to label your circuit breakers in the diagram. For simplicity, you can also use our port symbols to point to a system or bus that is not depicted on that particular sheet. Bus bars might be used to represent the physical bus that the circuit breaker is connected to. For Garmin LRUs that have HSDB, typically you'll see example architectures in the STC installation manual. This will help us sketch out the system architecture for the installation. It's important to remember that the architecture diagrams are a guide. They are not a requirement, and it specifically says so in the Garmin installation manuals, because there is not an example that meets every particular permutation out there for an installation. So in a case where you don't have a perfect match for an example architecture in the installation manual, just follow the requirements for the additional LRU's STC data. Sometimes there's phraseology such as must be directly connected to. Look for these items in the installation manual to know how to architect your installation. Consider that the higher order ports are generally higher priority, or basically higher criticality. You won't see a GTN number 2 connected to a higher order port typically. So here's an example of an HSDB architecture from the TXI installation manual. We have a GDU, GI275, and 2 GTNs. So when we're talking about higher or lower criticality or priority ports, you can see here that the port number 3, which is a lower order port on the GDU, is connected to the second GTN. The number 2 HSDB port is connected to the number 1 GTN, because the number 1 GTN is going to be higher priority or criticality compared to the number 2, the redundant GTN. So here's an example layout of a TXI installation with dual GI275s, a GDU 1060, and dual GTNs. Most of the connections have been made for HSDB and some RS-232 ports. For now, we'll just demonstrate adding the shielding and maybe some labeling for the connections. You can see here we've used the labels for the HSDB cable type here, and the shield symbology is clamped to this grouping of cables. So let's go ahead and add shield symbology to the number 1 GTN port 3 HSDB to the GTX45 port 1 HSDB. So we can right click to access the action menu, select the shield block, shield. You'll see that we have a toolbar that pops up here allowing us to change the modes. So we're currently in Snap to mode. You can see as we move the mouse, it snaps to the grouping of wires, but I'm not able to select all the wires. So let's go ahead and change that to click and drag mode. In click and drag mode, I'll click, drag my mouse, and select the wires I want to shield. And now you'll see that the shield is locked to this group. It'll even grow if you move the pin. We'll do the same thing over here. And we'll go ahead and add the label. You could see a lot of the layout techniques we've discussed have been implemented here. There are no crossing wires vertically for this pair. A lot of straight runs of HSDB cable for clarity. When they do cross other cables, they cross at a 90 and are very tightly coupled. The shield symbology also helps to distinguish between the cables. When showing HSDB connections, it's sometimes helpful to specify the type of cable that you'll be using in the installation as a connection label in the diagram. You can get the specific HSDB cables from the installation manual as defined in one of the tables. For HSDB signal integrity, it's common to keep both the A and B connections of the input or output pairs together on one twisted pair. So you can see the diagram of the HSDB cable below, where there are white and orange, orange and white, white and blue, blue and white pairs, as shown over here. Keeping the B's and the A's together as a twisted pair ensures the signal integrity and helps cancel out any interference. When you're working through the data path sheets, whether it's HSDB or any other combination of interfaces, your first step is to get all of your communicating devices onto the page as you're able to. So the LRU should be size proportionate to the number of connections. What does this mean? It means that, for example, your GDU, which most likely has the most connections, is going to either be on the left or right side of the sheet and drawn the largest proportionate to the other LRUs on the drawing. This allows you to place some of the smaller LRUs in the middle of the page to interface with the outer LRUs. So how do you get started? Well, what I like to do is start with the GDU and I'll ask, what does it connect to in my system? From there, once I understand what I'm connecting to, I can start looking at the relevant interconnects provided in the installation manuals. Not everything is going to be shown in one interconnect, so you're going to have to swap between multiple installation manuals and multiple diagrams within those manuals. For the GTN, there's the GPS interconnect, which shows you how to connect with either a single or a dual GDU interface. The GI275 is not covered by the TXI STC, so you need to swap over to the GI275 STC installation manual and refer to the GPS interconnect to know how it works with the TXI installation. Similarly, for other LRUs, if the data is not covered by the TXI installation manual STC, you'll need to go to that respective LRU's STC'd data. So we'll start from scratch laying out the LRUs on this page, getting them into their rough locations for an ideal layout. For this particular sheet, we'll focus on HSDB interfaces primarily, but if there's room, we can always add other interfaces as long as they don't crowd what's already on the sheet. So if you think back to the equipment that we're installing, we have a GDU, dual GTNs, and a GI275, all of which use HSDB. So let's get started with those and try to get these laid out. So to get started, add the LRUs from the templates. For the first one, we'll do the GTN 750. And if you recall, the Ethernet or HSDB pins are on the 1002 jack. So we'll select this one and select the Ethernet pins that we need, or ports. You can search by Ethernet and you'll see we have Ethernet in 1, through 4. For now, let's put 1, 2, and 3 on the connector. So we'll scroll down here and select all of the 1s, and we'll go ahead and select all of the 3s, and we'll select all of the 2s. Alright, so we have all the HSDB pins selected here. We can go ahead and add that to our drawing. Places it on the page automatically for you. And again, this is maybe one of our larger LUs, not quite as large as the GDU in terms of number of interfaces or connections. So it'll be fairly big, and you'll probably want it on the left side with the connector facing out to the right. To go ahead and make sure we don't crowd the page, let's go ahead and make the LRU larger and expand the connector so we can start spacing out these various pins. You'll want to keep the 1s, the 2s, and 3s close together since they'll be all under one cable. For now, let's move the 1s down to the bottom. So you can hold down Control, Shift, and just click on the Ethernet 1 pins. And just clicking on one of the pins and dragging, they'll all drag together. So we'll move these down to the bottom, and then we'll find the 2s, 2, 2, 2, 2, and we'll move those maybe right here. And we can leave the 3s where they're at right now. Let's go ahead and rename this to 750 number 1. Now we have two 750s, and assuming we're using the same number of ports, let's just go ahead and duplicate this one. And we can rename this one to 750 number 2. Now, like I said, we also have the GDU. Let's go ahead and find the GDU that we'll be using. It'll be the 1060, and if we recall, the HSDB is on jack 2 of the 1060. Again, let's filter down by Ethernet. We'll want to use the Ethernet ports 1 through 4. So let's get started selecting those. Okay, we have all of the HSDB pins in. For now, that's all we'll add on this LRU. Now, like I said, the GDU is likely going to have the most interfaces. So let's make it excessively large over here, and we can resize it later on if we have room. Let's go ahead and move our number 2 ports down. So Ethernet in out 2A, and we'll get the other 2s together down here. Probably bring in the 1s next. Bring these together. And then 4 and 3. So we have 3 down over here and 4 over here. Great, so now we have the primary LRUs laid out. So now let's add the GI 275. Alright, so we have on 2751 our Ethernet pins. We'll add both of those, both port 1 and 2, and let's just place that somewhere in the middle as it's likely going to interface with the GDU or the GTN. The architecture for this particular installation calls for HSDB number 2 on the GDU to interface to HSDB number 2 on the GTN number 2. So let's find those. We have HSDB number 2 on this GTN, and it needs to interface to HSDB number 2 on the GDU. We can either hit the Quick Connect tool or do Control Q to enable the connection mode. This way, we can go ahead and start connecting those pins. Ethernet in 2A goes to Ethernet in 2A goes to Ethernet out 2A. In 2B is out 2B. Out 2A is in 2A. And out 2B is in 2B. So now you can see we need to space out these connections a little bit better. And make it straight across if we can. So we'll leave these where they are, the GTN, and we'll go ahead and move these pins downward. Now you can see there's crossing over here because our pins are not aligned left and right to be straight across. To fix this, if you highlight over this one, you'll see this one is going to the bottom pin over here. Let's just get it out of the way and move it up top. This one's straight across, this one's straight across, and this one's crossing. So let's move this one out of the way. Now you can see these connections clearly. Now if you move the pin, the connections will snap as they get close together. So this one should snap there, snap, and snap. Great, now we can add our shield symbology. Just use the action menu with a right click. Select the shield block grounds as defined in the installation manual. And you'll see we can't select all of these at once. So we'll need to change the mode to click and drag mode. So we'll click, hold, and drag to select all of the connections you want to shield. And now it's locked onto these LRUs. If you move it up or down, it resizes with the connections. So we'll go ahead and connect all of these up per the architecture, whatever it is you've drawn up for this particular installation. So now you can see there's a couple of different problems that we need to solve in terms of this layout to make it easier to read. The first problem is over here on the left. They're daisy chaining from 1 to 3 over here. Port number 1 on 750 number 1 to port number 3 on 750 number 2. So you can see here these two wires cross. If you do it this way, they cross up here. Well, the only thing we need to do is just move the pins down here or on either side. You can choose. So I'll move these pins up here. And that fixes that crossing problem. And so you can space these out to make it look a little bit nicer. The other problem is we have crossing wires over here. These come down and cross, and they do stay pretty close together. It's not that terrible of a look. But you can still optimize this by moving these pins above the wires it's crossing. And so what we'll do is, to give a little bit more space between these other two ports, let's select all of these on either side. Click one and drag them down, and you can see we're moving them both together now. Great, but we still have another issue to address. I haven't connected port number 2 on this 275 to port number 3 on this GDU. So you can go ahead and connect them like this, but you see you have the wire going all the way around. In a situation like this, the best thing to do would be just duplicate the connector, and we will move it over here. And then let's go ahead and resize the LRU to give spacing between the labels. We could delete these over here. We don't need them anymore. We're going to use them on this duplicate connector. So get rid of the ones, we don't need those. And here we go. Now we've got the Ethernet over here. We can resize that. And now we can go ahead and connect them straight across. 2A in goes to 3A out. And similarly, get these all lined up. So now you can see, while the pins aren't grouped together tightly yet, the layout is pretty close. We don't have any crossing wires, and we don't have any crazy paths looking like a maze like we were going to have on this LRU. The audio panel should be your largest LRU on the page. With audio interfaces, it's important to ground only one side of the shielding to help prevent ground loops. So where do you start when you're creating an interconnect from scratch? What's the hardest part about pulling together a complete interconnect that might span multiple installation manuals? Drop a comment and let me know. Here's where the power of SkyWire Studio really comes in. After you've created one or more diagrams, you can begin speeding up your future diagrams through our templating features. So we have what's called a block template, which allows you to capture common configurations. For example, you could have one sheet that shows all of the base connections for a GI275, or maybe a dual GI275 or a single GTN connection, and create a template from that sheet that you can then drag and drop into any other sheets. So in this way, you can mix and match your diagrams from your library of templates to create any number of configurations. If you're creating a lot of custom LRUs, whether it's for equipment not in the system, like a FLIR ball or some other odds and ends, or just something that you want to display differently outside of a typical symbol, you can create a template for that custom LRU and keep it private or share it with the community, where we have a large community library of other custom LRUs for you to use.